If you're an electrical engineering student like me, you've probably heard of Tesla coils before. You can witness the plasma that they emit, power components and devices wirelessly, electrifying nearby metal objects, and so much more. They're quite interesting to watch and toy with, and there are many different variations of said devices. In this case, the one being shown is the solid-state Tesla coil, where a spark gap is not needed to create an oscillation. But this is besides the point. We're going to be focused primarily on spark gap Tesla coils instead. Early Tesla coils needed a capacitor bank of some sort to provide the charge to activate the spark gap. Technically, a capacitor bank isn't essential to a Tesla coil. All a spark gap Tesla coil needs is a temporary burst of high voltage across the primary coil in order to work. Heck, you can even use a stun gun to power a Tesla coil, though it likely won't be impressive. The same property that allows the Slayer exciter schematic to operate with an open circuit can also be used to supply that burst of power. This property is called parasitic capacitance. Parasitic capacitance can be ubiquitous in regards to electrical circuits, but can certainly be harnessed by having two conductors separated by a small area of air. Theoretically, you can have a chain of spark gaps to act as your capacitor bank by exploiting the parasitic capacitance between each lead. But there is a simpler and more adjustable idea to use. Instead of using a fixed capacitor bank, you can simply use a breadboard. Not only do breadboards have metal leads embedded underneath their holes, but they also have plastic between each pair of leads, which actually makes them more powerful parasitic capacitors than spark gaps. Let's see the difference between using a capacitor bank and using a breadboard as a high voltage capacitor. Before we begin, I must let you know that I'm using a Flyback Transformer to supply the primary Tesla coil circuit with high voltage. Now, at the time I did these tests, my Flyback Transformer ran on a lithium 9-volt battery, so that's why it stops after a few seconds. If you want to power your Flyback driver for an extended period of time, don't use a 9 volts. Also, you'll drain the battery's power very quickly since the driver draws a lot of current. So, if my hypothesis on using the possible parallel capacitance in a breadboard is correct, we should be seeing corona as soon as I turn the coil on. Without further ado, let's try it out. My, not bad. Here's a small secondary coil I took from a PCB kit. The results won't be impressive, but you'll see the difference by how intense the krypton bulb lights up. As you can see, the breadboard is better for power density near the coil, while the capacitor bank is better for power distance due to frequency differences as shown by the spark gap. I hope you learned something from this. Leave a like if you did. Feedback is always appreciated. Thanks for watching.